Okay, so let's read this problem out. A ladder is being pushed up a wall at a rate of 20 inches per second. The base of the ladder, which is 300 inches from the wall, makes an angle with the ground. What is the rate at which the angle is increasing the moment the top of the ladder is 400 inches from the ground? So this is a new one. This is one we haven't seen before because it is a changing angle, right? We're not concerned about the sides changing, although they are changing. We are mostly concerned, we need to find where the angle's changing. So the first thing I'm going to do is I'm going to draw this. Change this up a little bit. Make it pretty big. Oops. So I got a ladder, and it's being pushed up a wall. I will actually make that a ladder. Okay. So, what do we know? Let's see. We said the rate the ladder is being pushed up the wall is 20 inches per second. So we'll call that A. We'll call that side A. And we know that DA, it's being pushed up the wall 20 inches per second. All right. The base of the ladder, which is 300 inches from the wall. So we know that's B, and we know that B is 300. Okay. What is the rate at which the angle is increasing? So there's our angle. We're going to use theta, right? What is the rate at which the angle is increasing the moment the top of the ladder is 400 inches from the ground? So when the top of the ladder, right here, is 400 inches from the ground, right here. So A, which represents the distance from the ladder to the ground, A is 400, all right? Now, before we move on, let's talk about what else we can find here. We've got A and we've got DA. We've got B, but it doesn't tell us anything about whether or not B is changing, all right? If we're actually pushing the ladder up the wall, it probably is changing because the ladder is going to come, let's see, let's change the color here. If we push the ladder up, the ladder is going to go in and it's going to go up. So DB is probably changing, but we don't know how. It's not giving us information, all right? C, which is the ladder here. All right. We don't know, it doesn't give us the length of C, but it does tell us that A is 400 and that B is 300. And if you look at that, it's a 3, 4, 5 triangle. So we can use Pythagorean theorem to find that C is 500. C equals 500. And we also know that C is a ladder, okay? The ladder's length will not change. It's a ladder. It's not one of those extendable ladders either because they're not going to get fancy on us. So DC, the rate at which C is changing, is 0. It's not changing. All right, so that's all the first part. That's where we collect our information, and we still do not know theta. All right, so that's good. So D is done. I'm going to go ahead and erase that. Give me a second because I don't want to lose the actual problem itself. Oops. Good. All right. So back to it. Next, R. What's the rate we're looking for? Well, we already talked about that. It wants to know the rate at which the angle is increasing. So we're going to say d theta. We're looking for the change in theta. All right. So what you need to do now is you need to think of an equation, right? We have to create some sort of equation where if I take the derivative, I'm going to have d theta. So our equation, whatever it is, has to have some theta in it. All right, I'm going to show you how to do this two ways. First is the way you do it with a calculator. Second is the way you do it without a calculator. All right, so first way, we're going to go ahead and make sure you look at your drawing here because I'm going to reference it a lot, but I'm not going to actually draw it. So we're going to start with sine of theta, right? Sine of theta is opposite over hypotenuse, right? Remember SOHCAHTOA? So sine of theta is going to be A over C. Sine of theta is opposite over hypotenuse, in this case, A over C, all right? Now, if I take the derivative of that, what am I going to get? Well, the derivative of sine is cosine theta. But remember, every time you take the derivative of a variable in related rates, we have to account for the rate at which that variable is changing. So, d theta equals, now this is going to kind of suck because it's A over C, so we have to do quotient rule, all right? Now, I can actually teach you a shortcut here. I told you you can never plug stuff in until you take the derivative. unless that variable is not changing. So look here at the equation, all right? We know that theta is changing, right? The angle the ladder makes with the ground is changing. We know that A, the distance from the ladder to the ground, the height is changing because the ladder is being pushed up. But C is never going to change, okay? C is not going to change at all because it's the length of the ladder. So we can actually replace C here with 500. And that's going to make taking the derivative of this easier. So let's go ahead and come down and take the derivative of A over 500. So you're going to get low 500 d high dA minus high A d low, the derivative of 500 is 0, over low squared. All right, so there's your derivative. Take a second to write that down because I'm about to erase everything and I'm going to just go ahead and start stepping stuff in. I'm going to write it down too. All right. So here it all goes. Dang it. All right. So now we're going to substitute. All right. So we know that dA, we got 500 dA on the other side. We know that dA is 20 inches per second. So we're going to have 500 times 20. 500 times 0 is going to be 0. So that's just going to go away. And then on the bottom, I've got 500 squared. All right. Over here, we've got cosine of theta d theta. And I know I'm looking for d theta, so I've got to find theta. All right, we've got to find theta. And this is what's called this is what I call pre-equation work, right? We got to do some stuff to the side. So we know from our original equation that sine of theta is a over c, but we actually have the values a and c, so we can say sine of theta equals, a was, let's see, what was a? A was 400 and c was 500, right? And so we can simplify that to sine of theta equals 4 over 5. Now, theta is an angle. All right, theta is an angle. So what we're going to have to do to find theta is we're going to have to do inverse trig. So we're going to have to go inverse of 4 over 5 equals theta. And we're going to have to use our calculator there to find the inverse sine of 4/5. So let me find my calculator here real quick. When I put in, make sure you're in radian mode. When I put in inverse sine of 4 over 5, I get 0.927. All right, so theta is going to be, get ready because that's all going to go away. Oh my gosh. Why does it keep doing that? I'm going to have to get back that 500 squared. So theta is cosine of 0.927 d theta. All right. So now we are going to simplify, right? So cosine of 0.927 is going to be 0.600. So we'll go 0.6 d theta equals, now over here, we got 500 times 20 over 500 squared. So we can actually cancel out one of those 500s because everything's multiplied. So this is going to become 20 over 500, which simplifies to, let's see, 1 over 25, I believe. So we got 0.6 d theta equals 1 over 25. And when you divide 1 divided by 25 divided by 0.6, you get d theta equals 0.067. And we need a unit, and when we're dealing with angles, the unit is going to be radians, and then in this case it was seconds. So radians per second. So we have solved for d theta. That is our answer. Cool. Easy. But what if nice. What if we can't use a calculator? What do we do if we can't use a calculator? Well, what we're going to have to do is we're going to have to skip a step, and we're going to say we can't. There's no way you can find theta if you don't have a calculator. So we have to somehow get rid of theta or get it to where we only have a d theta in the problem. And the way we're going to do that is we're going to start with inverse trig right from the get-go. So the inverse sine of a over c equals theta, right? Remember when we did that in the last problem, if we start with inverse sine, we just have the theta on the outside, so the only thing we're going to have, when we take the derivative, we're just going to have d theta. However, taking the derivative of this is going to kind of be a little more difficult, so let's start by making it a little simpler. Remember, c is not changing, so we can get rid of c, and we can put in 500. So let's go ahead and take the derivative of this guy. Hang on, let me pull my notes up here real quick. All right, so the derivative of inverse sine is going to be, get ready, 1 over the square root of 1 minus x squared. And x squared in this case is a over 500. A over 500. We got to square that. Times the derivative of x. And so again, we're going to have to do quotient rule. So we got low 500 d high dA minus high a d low 0 over 500 squared. All right? Equals d theta. All right, cool. So when we substitute stuff into that, I'm just going to start from that side every time. We know that A is 400, right? Yeah, so A is 400. So I'm going to go ahead and sub 400 in for A. Get ready because there it goes. So I've got 400 here. I know that dA is 20, so I can get rid of dA and put 20 in. So I've got 500 times 20. All right, a times 0 is 0, so this section of the problem is just going to go away. Pretty nice. And that's it. I've just got to simplify now. All right, so let's talk about how to simplify this thing first. Well, just like in the last one, I got 500 times 20, and I've got 500 squared there. So I can take out a 500 from each of those, which is going to leave me with 20 over 500. And 20 over 500 is going to simplify to 1 over 25. So that whole big section there, I can simplify to, make that multiplication again, 1 over 25. Easy, all right? Now, 400 over 500 squared. That would suck if we could not simplify 400 over 500 to 4/5. So that's actually just going to be 1 minus 4/5 squared. Let me get rid of that real quick. I'll rewrite this to make it look pretty. So we got 1 over 4/5 squared. All right, so we got 1 over root 1 minus 4/5 squared times 1 over 25 equals d theta. I'm going to take this off so that my last section here, I can make it nice and big. So continuing to simplify, I'm going to have 1 over the square root of 1 minus 4/5 squared is going to be 4 squared over 5 squared, so that's 16 over 25. Right, times 1 over 25 equals d theta. Now, if I want to simplify this guy right here, I can make 1 25 over 25, so it'd be 25 over 25 minus 16 over 25, so that's going to be 9 over 25. So we got 1 over root 9 over 25 times 1 over 25 equals d theta. Next step, root 9 over 25 is going to simplify to 3/5, so I'm going to have 1 over, and this is all the same step, right? I'm just simplifying here. 1 over 3 over 5 times 1 over 25. 1 over 3/5 will simplify to 5 over 3 times 1 over 25. And then before we simplify that, we can go ahead and we can cross simplify. So 5 is going to go into 25 5 times. So 5 becomes 1. 25 becomes 5. And d theta, after all that, is going to be 1 over 15. And don't forget your units. That's going to be radians per second. Now, you'll remember from the first one we did that the answer was 0.067. If you do 1 divided by 15, you are going to get that answer. So the long story short is, if you don't have a calculator, you're going to want to use inverse trig, and now you know how to do it both ways. Oh, before I stop, one more thing that I want to add. If you have a practice problem and they give you the angle, right? We didn't have the angle here. If they give you the angle in the problem, it's actually going to be a lot easier. You can do it the original way we did it because you already have theta. So that's really the hard part there. So if you have theta, just know that you're going to be doing it a little bit differently. Okay, now I'm done.